Good day, I am Jerremiah Villaflor of Bsit 2A BPO. I'm here to discuss the introduction of IT 222 Networking 1. First, we have data communication. It is the exchange of data between two devices by some form of transmission medium. A data communication incorporates several techniques and technologies to enable any form of electronic communication. For example, a common example of data communication is a computer connected to the internet via a Wi-Fi connection, which uses a wireless medium to send and receive data from one or more remote servers. And we have 5 characteristics of effective communication. First, it uses the same transmission medium and language. Direct and indirect communication. Direct communication, ito yung mga through in person, like kausap mo siya ng pwedeng video call, ganyan. Then, kapag indirect communication naman, ito yung through written siya. Basta lahat ng type na written. And we have mutual understanding. Continuous process, use of words as well as symbols. Data refers to information presented in whatever form is agreed upon by the parties creating and using the data. We have 3 fundamental characteristics of data communication. First, we have delivery. Delivery, the system must deliver data to the correct destination. Diba natin yung kapag may ka-text tayo, ganyan, naro-wrong send tayo, dapat kailangan nating ma-deliver ito sa tamang tao o kaya sa receiver. Accuracy, the system must deliver the data accurately. Yung accuracy, ito yung ano ba to? Naaayon siya, ganun. Then, timeliness, the system must be deliver data in a time manner. Timeliness, ito yung dapat ma-deliver yung message sa ng on time, parang ganun, para iwas yung delay. Then, we have a components of data communication. First, we have a message. It is the information of data to be communicated. Then, we have sender. It is the devices that sends the data message. Receiver, it is the device that receives the message. Medium, it is the physical path by which a message travel from sender to receiver. Protocol, it is a set of rules govern data communication. And we have data representation. First, we have text. In text, we have ASCII. ASCII stands for American Standard Code for Information Interchange. ASCII code represent text in computers, telecommunication equipment, and other devices. And second, we have eASCII. eASCII stands for Extended American Standard Code for Information Interchange. It is 8-bit and larger encoding that include standard 7-bit ASCII character, and we have Unicode. A Unicode, it is information technology standards for the consistent encoding, representation, and handling in text expressed in most of the words written system. And we have ISO. ISO, well, is the standard as ISO 8859 describing its own set 8-bit ASCII extension. And we have in data representation number 2. In number 2, we have numbers. It is a numeric data consists of numbers can be used in arithmetic operation. And we also use in data representation the images, audio, and videos. We have a data flow. In data flow, we have the simplex. In simplex, communication is unidirectional. Half duplex. Each station can both transmit and receive but not at the same time. Full duplex. Both stations can transmit and receive simultaneously. Network criteria. We have performance. It can be measured in many ways. We have transit time. It is the amount of time required for a message to travel from one device to another. Response time. It is the elapsed time between an inquiry and a response. The performance of the network depends on many factors such as a number of users, type of transmission medium, capabilities of the hardware, and efficiency of the software. Then, we have reliability. It is measured by the frequency of the failure, time it takes a link to recover from failure, and a network robustness in a catastrophe. And we have security. Security, it is how the network protects data from an unauthorized access. We have the categories of a network. In a network, it is categorized with the following factors. We have size, ownership, distance it covers, physical architecture. We discuss it later. And we have the categories, the local area network or LAN. A local area network, it is a collection of devices connected together in one physical location such as building, office, or home. A LAN can be a small or large. And we have metropolitan area network or MAN. It is a computer network that connects computer within metropolitan area, which could be a single large city, multiple cities, and towns. And we have wide area network. A wide area network, it is a collection of local area networks and other networks that can communicate with one another. A wide area network, it is essentially a network of networks with the internet, the world's largest one. And this is the categories of a network. We have the LAN, we have the size, ownership, distance, architecture, and example. In LAN, we have building or campus. In ownership, in LAN, we have privately owned. In distance, in LAN, few kilometers. In proper physical architecture, we have bus, star, and ring. And we have the example, the laboratory network. And in MAN or metropolitan area network, in size we have cities. In ownership, public company. In distance, and in distance we have extend over entire city. And we have in physical architecture, we have LAN to LAN. And example of MAN in is cable network. In wide area network, the size is globe. Ownership, private or public. Distance extend over entire globe. Physical architecture, we have man-to-man. And example is internet. So, we have a networking. It is a group of connected communication devices such as computers and printers. And we have the mid-1960s stands alone devices. We have ARPA Advanced Research Projects Agency. DoD, it stands for Departments of Defense. And in 1967, we have HCM, Association for Computing Machinery Meetings. ARPANET. IMP stands for Interfaces Message Processor. And in 1969, we have ARPANET Reality. We have 4 nodes. First, we have University of California, Los Angeles, or UCLA. And we have University of California, Santa Barbara, UCSB. And 3 stand for Research Institute for University of Utah. And we have NCP or Network Control Protocol. And in 1972, we have Wind, Surf, and Bobgun Interneting Project or Transmission Control Protocol or TCP. We have encapsulation, wrap, then unwrap. Datagram, UDP, prioritize time over reliability. And functions of gateway, gate between two networks. And we have shortly thereafter TCP to TCP higher level function. But first we have segmentation, second reassembly, third error detection. And in IP handle datagram, TCP or IP Internet protocols today. And we have physical topology. Physical topology, it refers to the way in which a network is laid out physically. Categorized in mesh. Mesh is the communication is point-to-point. Bus, it is the signals are shared with the backbone cable. And stars, signals are passing through the central device. Ring, signals are circulate within the network. And we have the advantages and disadvantages and features of topology. In mesh, we have point-to-point link. In advantages, robust, privacy or security. In bus, we have less expensive than mesh, ease of installation. Star, point-to-point link, robust, less expensive than mesh. Ring, point-to-point link to both sides, only easy to install and configure. And in disadvantages, in mesh, we have expensive in cable and I/O connection, and sheer bulk or of wiring. In bus, we have difficult reconnection, difficult to add station, and we have limited number of station. And in stars, the disadvantages is using central device. And in ring, we have disadvantages, which unidirectional traffic of signal. And we have a feature. The feature of mesh is N-1 in connection, bus, backbone cable, star, hub, ring, and repeater. And That's all for today. I hope you learn a lot from me. Bye. Thank you.